Okay, so the final lesson is on the solubility of compounds. So let's just look at some vocabulary around solubility. So solubility is how likely a solid will dissolve in a liquid. Now, when you have a solution, you have a solute, which is the solid that's being dissolved, and the solvent, which is the liquid in which the solute is dissolving in. So let's look at intermolecular forces. So intermolecular forces, as we've previously discussed, are the forces which attract molecules to each other. So here we have two hydrochloric acid molecules. You have a strong covalent bond between the hydrogen and the chlorine, but a very weak bond between the hydrogen and chlorine of different hydrochloric acid molecules. So what happens is that we have water. Water is a very polar molecule, so therefore oxygen is very electronegative and hydrogen is not very electronegative. So the OH bond is very polar. There's a positive section, the H, and a negative portion, or negative pole, which is the oxygen. So the electrons favour the direction of the oxygen. So in terms of water, the electrons involved in the bonds sit very close to the oxygen atom due to its electronegativity. This leaves the hydrogen atom as a bare proton and its associated positive charge. This makes for a very polar molecule, as you can see from the diagram. So you also get water-hydrogen bonding. The bare proton of the hydrogen atom of one water molecule is strongly attracted to the lone pair electrons of the oxygen atom of an adjacent water molecule. This holds waters together in molecules, or the molecules of water together in terms of clusters, and this is known as hydrogen bonding. Very important. It's the reason why water is a liquid and not a gas at room temperature, because it requires more energy to break these very specific intermolecular bonds known as hydrogen bonds. So in terms of dissolving, for a substance to dissolve, the solute to solvent interactions must be similar or stronger than the forces within the solvent and the solute. So using the example of water, it means that water, or the bonds between the water molecule, have to be stronger, well, the water molecule and the substance being dissolved have to be stronger than the interactions between the atoms in the substance being dissolved. So here's an example of a polar substance dissolving. So here we have the water molecules. We have, say, a lattice, say sodium chloride, or in this case sugar, and it's being put into water. So the first thing that happens is the polar sugar molecules are attracted to the water molecules. Okay, so for example, the negative portions of the sugar molecule are attracted to the positive proton of the water molecule, and the positive parts of the sugar molecule are attracted to the negative oxygen atom of the water molecule. And this causes the lattice to begin to get broken up, because the bonds, or the interaction between the water molecule and the individual sugar molecules, is stronger than the intermolecular bonding between the sugar molecules. So the sugar molecules are now known as being hydrated, surrounded by water, and the single sugar molecules can then go into solution. They have been dissolved. Similar with ionic solids. So here we have a block of sodium chloride, the positive grey sodium, the negative red chloride, and it's put into water. So again, you've got the water molecule. Okay, so the next step is that the charge ends of the molecules are attracted to the ions of the opposite charge. So the positive sodium ions are attracted to the negative oxygens of the water, and the negative chloride ions are attracted to the positive hydrogens of the water. Okay, and therefore the lattice begins to split up, because the attraction between the water molecules and the ions is greater than the attraction between the ions in the lattice. So it ends up with the ions being surrounded by water molecules, and they're called hydrated ions, and the free ions then go into solution. So in terms of nonpolar dissolving nonpolar, organic solvents such as cyclohexane or heptane or butane are nonpolar molecules. So therefore they'll dissolve other nonpolar substances because their intermolecular forces are similar or weak. And this is a diagram there of octane and benzene being able to dissolve in each other because of the dispersion forces between the molecules. And finally, why they don't like each other. Polar molecules won't mix with non-polar solvents. This is because the polar molecules are more attracted to themselves than the non-polar molecules, and because of this, they tend to stick together, and they clump, and they don't actually dissolve. And that is the end of the lesson.